Hey, you 12s, thanks for coming, guys. Welcome to AS Organic Chemistry Lesson 1, the intro. So, I'm going to crack straight on today, guys. I'm not going to waste any time. So, lessons up on the YouTube, get rid of that. There we go. Right. So, this is AS Organic Chemistry Lesson 1, and this is intro. Intro. Learning objectives. No, number 1. Know your formula types for organics. Number 2, know the 10 homologous series for AS, and then be able to name branched alkanes. First step in the naming process, name branched alkanes. Okay, so now you guys have been doing organic chemistry since about year 9 GCSE. So you guys should have a pretty good feel for and a pretty good base knowledge for organics. And you've already met some of your families. So I'm half tempted to let's start there. So I'm actually going to do learning objective number 2 first, since I think that's a good place to start. So the AS families. Now, just to say, by the way, families. The word families is not really used in chemistry. We use the term homologous series. So the question is, what does this mean? Yeah, well, the word series means a list in order. It's a list, yeah, or a group. And this homo means same, logos means family. So these are the same families, but this actually has itself got a definition. So we need to define a homologous series. And we can name some of their features, do all that kind of stuff. A group of molecules with the same functional group. Now the word's functional group, this means active, I'll put active section. Yeah. We realize that different parts in organics gives it their properties. So we also realize a group of molecules with the same functional group. Yes? So therefore, the second bullet point is therefore similar chemical properties. So for example, any organic molecule that has an alcohol group will get you drunk. They'll also kill you, but they'll definitely get you drunk. Therefore, similar chemical properties. There's one more as well, which is their physical properties increases in a trend with chain length. So, and physical properties increase in a trend. Increase in a trend with chain length. So, for example, let's have a look at a homologous series. So, let's just do one of my favorite groups. So, as soon as you see this section, Yehern, what's this? That little section, the purple bit, what's that do? Second? Well done, spot on. This is the active part. This is what makes an alcohol an alcohol. This is called the alcohol functional group. Yeah, functional group. The section, the unit, the part that infers the chemical properties. So we have methanol. Then we can go to the next one in the series. I'm going to ask Louis. Name it, please. Thank you very much. This is our favorite molecule, isn't it? Our Friday night molecule, Louis. Not that you've ever tasted it. Of course not. Never. But once again, the same functional group. Yeah, still an alcohol. Yeah, but now instead of methanol, this is methanol. This is now ethanol. But it still has the same family ending. And we can now predict the physical. Let's do one more. Oh, one more. Yi Hearn, can you impress me, please? Nice and loud. You're going to have to shout over the mask. Nice and loud. Well done. Good effort. So you've given me the perfect GCSE answer. Alcohol still. And so Yi Hearn's given me IGCSE. Can I just say how impressed I am? Well done for remembering. It's been a long time since you've looked at this, Yi Hearn. I can't even remember what I had for dinner yesterday. So well done. Really pleased. This is propanol. I'm going to say, Louis, any ideas how that's going to transition to A level? Okay, that's fine. If you don't know, it's okay. It just means that your teacher's never told you. It's fine. At this point, I'm going to go to my chat just to check that people are there. Hi, Mita. Lovely to see you. Sorry, it's taken me a bit to reply. Won't you finish the IGC? Oh, Mita, of course I will. I'll finish it today for you. I'm sorry I haven't got round to it. I've just been crazy busy. So I'm just going to quickly ask Anch or Harry, who I taught GCS. Well, Harry's done a classic mistake there, but a good effort, Harry. Well done. So Harry has done propanol, and he's forgotten a key bit, which is it's propanol. Can't forget the an, Harry. It's still an an. Yeah. I'll be doing naming with you guys soon, I promise. But that's the difference. That's actually at A-level propanol. Louis, would you like to tell me why it's a 1? I like it, because we're going to put it, it's on carbon number 1, which is the lowest number. Well done. Good man. So the great thing is we can now predict their physical trend, boiling point. So I'm going to ask Louis. Louis, out of these 3, who's going to have the lowest? Of course. Thank you very much. Lowest boiling point. I'm going to ask Yi Hearn on your mobile phone, please. Can you just Google for me the boiling point of methanol? I can then tell you that ethanol is 78 degrees, because yes, I'm that much of a nerd. Louis, what do you think is going to happen to propanol? I like it. It's going to go up. I don't know if it's going to be 100 plus. That's a big jump, that. But it is definitely going to be higher. Methanol, 64.7 degrees. I like it. And then ethanol, I know it's 78. Can I have propanol, please? $97. Whoop, whoop. So, physical trend, physical property, physical prop increasing with chain length. We know this. Increase with chain length. Now, I'm going to ask Louis to impress me. Louis, what type of intermolecular forces are present in all of these 3? By the way, you're not going to mention that, though, are you? Because we don't care about that. Because what's there? Well done. We know we're going to see hydrogen bonding because we've got all the fun. Yeah, but Louis, you've actually said a really cool thing. So why does the boiling point of these guys increase with chain length? Thank you very much. 2 very good questions. The increase here is due to increase in size. All show hydrogen bonding, HBs, which means that's not the problem, but MR increases as we go down, therefore more electrons, gotta state it. Next, so LDFs increase. Stronger LDFs, we're done, like it. More energy, gotta mention energy. More energy to break, I like it. More energy to break, to blame. Sorry, what? Cool. So it's nice to have defined our homologous series and understand what they are. We like it. Right. let's now do our families. Okay, guys. New title, AS fans. And there are 10. Okay, number one. The number one in the family list. I bet Yi-Hern can tell me what it is. Name the most common homologous series that you remember. I'll give you a clue. Yes, thank you very much. Family number one is the alkane family. Let's do an example. Let's go for this guy. Ethane. Gotta love a good bit of ethane. There we go. Next family, please. Louis? Thank you very much. Great job. The alkene family. And this one, of course, is ethene. I'm just doing the eths as many as I can. This is ethane. Ethane. This is ethene. Very important. Change in letter. Different family. Look, I've underlined the E with 2 lines. See what I've done? Not impressed. Oh. Okay, next one. By the way, I'm doing this one in red. Family number 3 is the alkyne family. Louis, why am I doing it in red? No, it's because technically you do not need to know this family, but they are expected to be able to draw them. This is ethine. You do not need to be able to name this family. Not named at A level, but you are expected to be able to draw them. Next. So we've gone alkane, alkene. What are you going to go for next, Louis? What I'm actually going to do, I'm actually going to do this one as like a star itself, so I can then just continue with number 3. That's a good idea, isn't it? 3. Go for number 3. Ooh, that's exciting. A halo alk. By the way, it's actually a halo alk ... Can you tell me why? Because you can have a halo alkane or a halo alkene. You can even have a halo alkyne. Yeah, what I'll do is I'll put alkane and we can draw one. Let's do the most famous. Oh, let's do the famous one. Check out this bad boy. Trichloromethane, otherwise known as chloroform. Any ideas, Louis, what chloroform? Why is that famous? I like it. It's always in the movies. It is. This is the stuff that knocks you out. Did you know? It's very first. This was actually one of the very first anesthetics. By the way, people often say, well, hang on a minute. What was the first? Well, the first one was alcohol. You guys have all seen the movies where, if you've got the guy's been shot and they've got to pull the bullet out and he swigs back alcohol. Yeah, they're using it as an anesthetic. Yeah, but in this case, this is the first real true one that we made that actually knocks you out. Now, just to say, you can have a halo alkene as well. You can actually attach a halo onto pretty much any group you fancy. Next, family number 4, alcohols. Let's add on my alcohol. And we're going to go for ethanol, our favorite Friday night molecule. There we go. Good old ethanol. Gotta love ethanol. Ethanol. There we go. Let's go for the family number 4. A carboxylic acid. A carbox. You had this at GCSE? You had it. It was on your list. You knew them. Let's go for the favorite one. Ethanoic acid. Yi-Hern, do you know what the common name of ethanoic acid is? No? That's okay. It's in the house. You put it on your fish and chips. You put it on your rice. When you make sticky rice. Has she said it? I just didn't hear it. Oh, okay. What was it, nice and loud? Vinegar. Sorry, I couldn't hear. I'm sorry. I didn't hear you with your face mask. I apologize. Common name is vinegar. There is another name for it. Louis, do you know it? Well done. Really impressed, dude. Well done. It does have another common name called acetic acid. There's vinegar and acetic acid. They're all the same thing. Its proper name. Now, at this point, I get to introduce you to IUPAC. Now, IUPAC, this is a nota bene. IUPAC stands for the International Union of Pure and Applied International Union of Pure and Applied Chemistry. Now, this is a group of about 6 old guys. And I mean old, they're like really old. They're like nearly dead. Like 2 of them died a couple of years back and they replaced them with young members. One of them was 71. You know, but that's considered young. Like these geezers are old. And these guys invented the naming system. By the way, shouldn't call it that. They invented the nomenclature system. By the way, the word nomenclature literally means naming. Don't even ask me why they call it that. There's going to be some derivation somewhere. So what they often say is the nomenclature system, which they just call the IUPAC nomenclature system. So what they often do is, so this here is the IUPAC name. Yeah, that's the IUPAC name. This one is by the way, acetic acid is called its common name. Vinegar is an everyday is a household name. I know it seems weird that you could argue that vinegar would be a common name, but and it kind of is. It just means that there's kind of multiple common names. That's all. I can give you some other ones as well. Have you guys ever heard of Teflon? Yeah, most of you guys should have heard of Teflon because it's on your frying pans. The proper name is polytetrafluoroethene. And they just went, let's just call it Teflon, shall we? Yeah, make it easier. So anyway, so carboxylic acid, family number 6, right? It's new, and it's bigger, it's better. Name the film. No one knows the film reference. So you are expected to know this one. I will do this new one in green. Number 6. This is an aldehyde. Let's have a look at it. Let's have a look at what it looks like. It looks like this. And I'm now going to, this one is ethanal. Ethanal. So what I'm going to do is, just to show you what bit's important, this bit here is the functional group. That is the funky group. Funky. You're not with me today. This is the functional group. Yeah. And the ending, and that's the ending there for aldehyde. Yeah, it's called a suffix. Suffix for an aldehyde. So it's just al. I know that Ansh is reading that and he thinks it's hilarious. Yes, thanks, Ansh, for that. I'm glad you find it so funny. I know Louis is also finding it very entertaining. Let's not talk about that, huh? Yeah, move on. Number 7. Number 7 is a ketone. These are all new to you for A-level. Right, this is the first one where I can't do an eth. Has everyone noticed that I've been enjoying the eths? Yeah, I've been doing as many eths as I can. Now I can't. Now the smallest ketone is propanone. Got to say it with an Italian accent. Don't ask me why. So the functional group is there. And it has to be joined to R's. Just a point, I'm going to draw that underneath in the picture, an R and an R. An R means any length carbon chain, just so you know. Nota bene, R is any length carbon chain, any length C chain. There we go. And this is propanone. There's the ending. There's the suffix for the ending. Own, which is in the name. It's quite nice that the own ending and the al, notice that they're subtly different, that the al went for the start of the name and the ketone went for the ending. They're trying to make them different. But this is a ketone, so this is a new family for you guys, number 7. Next one, number 8. Number 8 is a cyclo. So the cyclo can be cycloalk. It can be an ane or an ene. I'll put the alkane just for fun, just to show you what one of these bad boys looks like. Cyclo literally means inner circle. Louis, do you want to have a go at naming this for me? Well done, good man. Isn't that cool that this is a new family to you, but you can use what you already know and the family name to build it. That's kind of cool, that. That's sexy chemistry for you. Making stuff up, that's correct. Does anyone else feel like that says cydo-propane? Looks a bit like Cydo, right? I don't want Cydo. Cyclo. There we go, that's better. Cyclopropane. Another Italian one there, very Italian. We can do another one of these just for fun. Should we do an alkene just, for fun and games? How about this bad boy? How about this one? I'm going to ask Yehern. Have a go at naming this one, Yehern. Cyclobute. Ene. This one now picks up the ene. Yeah, because it's now got a double bond in it. Let's call that. It's just nice to show a couple. I don't want these two to get confused. I'll swing that one in my notes over to this side. Boom, look at that. Winner. Hello. I'll put the cyclopropane underneath it too. I love my little lappy. Hello, little laptop. Hello. Doing a good job. Doing good job. Don't do verses. Just extra. And won't let me rub out. Oh, you're not doing a very good job there, Lappy. Lappy's giving up on me. There we go. Right, so we now got the cyclos of the world. The cyclos. By the way, you can also have a cycloketone. Yeah, you could even put a double bond in there. I'm getting lost in the cyclos now. What about this bad boy? Louis, what do you reckon that's called? Oh, it's not an al, because look, it's the R. Yeah, well done. This is cyclopropanone. Cyclopropanone. Isn't that cool? Cool beans. Lots of beans. All the cool type. Right, number 9. We're doing really well. Doing lovely. Doing lovely here. Doing lovely. Number 9. Next is a nitrile. The nitrile family. So what does a nitrile look like? Let's go for the easiest one we can. This is ethane nitrile. Cool, right? Ethane with the E. Nitrile. So the functional group of this bit is this, C triple bond N. Yeah, that's the nitrile part. Yeah. And the problem is, because the nitrile starts with an N, and the ane has an N, you need the E, just otherwise it's going to become ethanonitrile. Just sounds like you've got a stutter. So they put the E back in to make it sound better. Yeah? Otherwise got stutter. Methane nitrile. Oh, can. Oh, but by the way, but that's now called hydrogen cyanide. That's now one of the most toxic gases we've ever invented. That's nasty stuff, that. You wouldn't bother calling it a nitrile because it now behaves as an acid rather than an organic family.
It's really tricky that, because you could argue that if they gave you that in an organic setting, they could ask it, but you would just call it hydrogen cyanide. Yeah, what a great question you had, Louis. Really impressed. Well done. Well done, lad. Yeah, but that's called hydrogen cyanide. That's the stuff that they used to kill the Jews in World War II. That was the stuff used in gas. Nasty, really, really horrible stuff. Right, your last family, family number 10, are amines. Let's look at an amine. I'll go for the eth. Why not? Let's stick with the eths. There we go. They're bringing your AS families. Now, can I just point out, there is actually one additional family which really annoys me. This, by the way, is called ethanamine or ethylamine. This is the old name now. This is old. This has now been deleted, but I have to teach it to you in case you see on an old paper. Yeah, ethylamine and ethanamine are the same thing. They have now updated it. This is now new. Yeah, oh, so close. This is now new. They were just trying to make it easier for people, which I actually think is quite nice. You know, how many times in the English language have they ever said, you know what, guys, let's get rid of that stupid rule because let's make it easier for ourselves, yeah? But yeah, the English doesn't do that. Chemistry does improve every now and again. So this is an amine, ethanamine. Now, I'm just going to add in one extra group. This is the end of year 10, by the way, for AS. But I'm just going to add in an IGCSE one, which is, by the way, this doesn't usually get asked at AS, just to make you feel better. They tend not to ask this. This actually comes back in at A2. But Edexcel, in their infinite wisdom, says, well, if they've done it at GCSE, we can ask it at A level. And every now and again it appears. So this is really a GCSE recap, which is esters. Now, this is actually an A2 family, but you covered it at IGCSE, which means they can name it, they can ask it. I'll give you the basic one just for your notes, which you guys should all recognize. Yeah, this odd thing where you have two chains joined together by the weird bit in the middle. Yeah. So here is ethyl ethanoate. This is ethyl ethanoate. And this is IGCSE, so it is worth doing a little bit of, every now and again they'll pop it at AS. Every now and again. Relatively rare. Right, guys, I have now introduced you to your families. And these families are so important because they're going to ask you for these. They're going to ask you to give the functional group, circle the functional group, name the functional group, and of course, then name the families. So, at this point, we have now introduced you to the 10. Right, I now need to do formula types. Right, new subheading, please. New subheading. Formula types. Okay, so you guys have been writing chemical formulas for years. I don't know, some teachers might have told you the names, other teachers might not have told you the names. So the first one that, of course, we know is number 1 is molecular. Everyone knows this. The molecular formulae. Molecular formula. Yeah, and this is the actual number of atoms of each element in a compound. We know this definition, we've had it for years, haven't we? Yeah, the actual, capitalized, notice, actual number of atoms of each element in a compound, Right, then we get number 2. By the way, let's do one. Oh, got an idea. It's gone. Damn it, my idea's gone. I don't know idea when it's gone. Hang on. No. Yes. Right. So what that formula tells us is there's 2 carbons, 6 hydrogens, and 2 oxygens. Everyone okay with this? Right. Then we know the empirical. We know this. The EMP form. Empirical. formula. This is the simplest whole number ratio of atoms of each element in a compound. Notice my capitalize, the simplest whole number ratio of atoms of each element, simplest whole number ratio of atoms in a compound. Of each element, no, it has to be of each element. Atoms of each element in a compound. And the reason why I gave you that one above is because we can simplify it, can't we? Yeah, we can now simplify this to CH3O. Right, can I just now put a clause on this? Empirical formula, pretty useless. Pretty useless. It's basically all for calculations. You can't really do much with an empirical. It's kind of garbage. Doesn't really allow you to do anything with it. Pretty useless. Right, now we start getting the organic stuff. Now we start getting the cool stuff. So, the next one is called displayed. You guys have been doing this for years. Displayed formula. A pictorial representation of a compound showing all bonds. Boom. Let's draw it out. All bonds. Can I just point out, there is a very common mistake in here, and this is not your fault, it's the internet. The internet is an amazing resource, but it's also full of garbage chemistry. Yeah, if you look that up, this bond commonly disappears, and it doesn't half do my head in, because if they ask you for displayed and you draw that, you're done. Yeah, so let's have a look. We've got ethanoic acid. I probably ought to type in, ethanoic acid. Let's go molecule, and look what happens. Look what happens. The bond vanishes. Yeah, loads of them do it. Look at them. No. Sorry, I've lost it. I just start barking at the internet when they do such garbage. Look at it. You're doing. Stop it. Ugh, ruining my chemists. Don't make the most. Can I just point out? It's not even. It's even more frustrating than that. That's the most important bond in the whole molecule. Oh, I don't know. Let's just go there. Idiot. Next, number 4 is skeletal. Skeletal. This will be new to you guys. Skeletal formulae. Right. So a skeletal formula, a pictorial representation. A pictorial representation showing carbon backbone and functional groups and funky groups. Let's have a look. Let's have a look at what this looks like. Okay. I've made it awkward. Oh, I've made it awkward for myself. Oh no! Oh, I've made it. Oh. I can't actually do ethanol. You can, but it looks stupid, and it actually literally becomes this. That's the skeletal of ethanoic acid. It's really stupid. Just to point out, you wouldn't actually draw it flat. You'd draw it like, but then it looks weird, doesn't it? Like it's so stupid. So just to give you more here, because at this point I've got to show you what. So propane, everyone knows propane. We've been drawing propane for years. Yeah, propane becomes this. There's the only functional is the single bonds. So there's no other pick. That's it. That's propane right there. How cool is that? Oh, It's an L. Oh, sorry, what? I'm sorry. Sorry, it's not, there you go. This is propane. Let's do another one. Here's butane. Check this out. Here's butane with all its sticks. Just H's on those, by the way. I'm just being lazy. There's butane. Check it out. Boom. Look at that. It's kinky. Oh, kinky butane. Oh, it's a kinky butt. Oh, I'm going to move on. Sorry. If you want to know what an alcohol looks like, let's do this. 1, 2, 3, 4. Let's make it a ketone. Boom. Propanone. Hello. No, pentanone. Pentanthreone. There you go. It's like an albatross. Yeah. So you've got a kinky chain. It's got a kinky chain. And then your key. By the way, the ketone, I could have done it like this if you preferred. If you'd wanted me to do this, I could have totally done that if you prefer me. It makes no difference to me there. Check that out. So all you're doing is turning the carbon chain into lines. It just makes it easier. And let's do another one. Let's do a branched one. How about this guy? Methyl propane. All sticks for H's. Yeah. But that now becomes this. Yeah. Showing a branch. It's nice to kind of have all these examples to see what each thing is doing. Right, so we've covered skeletal. We're on to the very last one. Well, that's amazing, isn't it? Number 5, last one. Number 5, and the last one is structural. The one everyone hates. Structural formula. The reason being is this is probably the hardest one to get used to. It's the trickiest one in terms of the chemistry language. Because you have to, this is actually a written formula showing the arrangements of the atoms. So this is a written formula, is that spelled written? It's written got one T or double T? It's double T, right? Yeah. A written formula showing arrangement of atoms. I'll show you what I mean. And that is, let's go for ethanoic acid. So here's the displayed, and I'm going to convert it to a structural. And what I do, it always starts with a C. So that what I'm going to do is I'm going to translate this C first, which is CH3. This here translates to a CH3. And then this section, which is the ending, COOH. It's a coo, it's a pigeon. Yeah, carboxylic acids are pigeons. Let's do some more. Let's do this guy. Gonna ask Louis. Louis, what family? What family? What homologous series? Well done. Look at that. Louis knows what he's doing there. Spots his alcohol group straight away. Yeah. So we can now turn this into all of them. Number 1, let's go molecular. C5H. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh. Then we can go empirical. Oh, it's the same. Then we can go skeletal. 1, 2, 3, 4, 5. Ah, now this is clever. I can't put the O there because it means the carbon wouldn't be there. So I actually have to add a stick with OH on it. Yeah, but there's no carbon at that. You know, that you're not going to have a carbon on top of the C, are you? Yeah, so it's just the OH. There you go. There's the skeletal version. But Louis, what did you call this? Can you add the number for me, please? Well done. Pentan 1-all. Good lad. Well done. So there's the skeletal. Now we can change to structural. CH3, CH2, 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 OH. You just read it left to right. You get used to it after a while, guys. You do. It just takes practice. It is a language. And that actually brings me to the end of my lesson today, which is amazing. We've covered all types. Now, what I'm going to now do, guys, is in terms of teaching you, so we've now on naming branches. Yeah, I'm not going to do that today. I'm going to do nomenclature in one go. Well, maybe 3 lessons in total to do organic naming. So I'll pick this one up. I'll pick this one up next time, but I will leave it today there. So you've got 10 families to learn with structures that you've got to start picking up. Yeah, it takes a while. I know it does. Yeah, and different types of formulae. Definitely a good intro lesson there today. It's been quite a lot of fun. Enjoyed that. I will end it there. Guys, I hope you have a nice rest of your day. I will see you all tomorrow for organic naming. I will see you all soon. See you later, guys.